So, ladies and gentlemen, the trick is we want to find, so looking at problem number 1, we want to find the exact value of sine of pi over 12. Pi over 12 is not on our unit circle. So the only way we can do exact value now is I've got to find a pair of angles that I can add or subtract together that are unit circle angles to give me pi over 12. So when you're looking at something like this with a denominator 12, what you need to do now, we know there's pi over 3, there's pi over 4, there's pi over 6. Think of what those fractions look like with denominators of 12. So for example, I know pi over 6 is equivalent to what? 2 pi over 12. I know that pi over 4 with a denominator of 12 is equivalent to what? 3 pi over 12. Pi over 2 is equivalent to what? 6 pi over 12. I know pi could be written as 12 pi over 12 pi. There is more than one correct pair of angles that could be picked that you could add or subtract together to give you that particular angle. So what that means is when you're doing your homework tonight, you may do using a sum of 2 angles. Your friend may be using a difference of 2 angles. Well, that doesn't mean in the end you're going to get the same answer. It just means that you pick different formulas, so your work's going to look a lot different. All right, so for example, I'm giving you a hint here. Pi over 4 minus pi over 6 equals pi over 12. What operation am I doing between these 2 angles? I'm doing what? Subtracting. So I'm going to use my difference formulas. And again, I want to find the sine. So on my pink sheet, what happens is I'm going to use my sine difference formula. Now, I've introduced the Greek symbol theta to you to represent an angle measurement, a variable that's an angle measurement. These symbols here are 2 other Greek letters that we use to represent angle measurements. They're other variables. So alpha and beta. All right, so all they are angles. So what you need to do first of all is copy down right from your formula sheet what formula we're going to use. We're going to use the sine of alpha minus beta equals sine alpha cosine beta minus cosine alpha sine beta. That's the formula that's applying because I want to find the sine of the difference of 2 angles. Now, what 2 angles did I subtract to give me pi over 12? Pi over 4 minus pi over 6. Remember, the order in which you subtract matters. So the first angle here I'm going to call my alpha angle. Pi over 6 is my beta. So now what I want to do into my sine difference formula is I'm going to substitute in an alpha for pi over 4, or pi over 4 in for alpha, and substitute in a pi over 6 for beta. So then the sine of pi over 12 is going to be equal to the sine. Alpha is my pi over 4. Beta is my pi over 6. Minus cosine alpha, so I'll plug in pi over 4 for alpha, and then plug in pi over 6 for beta. So all I've done at this point is substitute. Remember, we're trying to find the exact value of sine of pi over 12. And the way we do this is we lean back to angles that we do know from the unit circle. So now it's a matter of going back to the first unit and remembering your unit circle. What is the sine of pi over 4? Square root of 2 over 2. So I'm going to substitute in, take out sine of pi over 4 and plug in square root of 2 over 2. Times. What's the cosine of pi over 6? Going back to your unit circle. Square root 3 over 2. Minus cosine of pi over 4, square root 2 over 2, times the sine of pi over 6, which is 1/2. That's where I said, guys, if you don't know that unit circle, this is going to be a disaster. You've got to know that unit circle. All right? That's now just a step in the process. So now, any questions on what I've done? So now I need to clean this up. How do you multiply fractions together? Because now remember, follow your order of operations. You want to multiply before you subtract. How do you multiply fractions together? Just multiply straight across. Square root of 2 times square root of 3 is square root of 6 over 4 minus square root of 2 times 1 is square root of 2 over 4. So I can condense this to square root of 6 minus square root of 2 all over 4. Okay? Make sure, I should not have to tell you at this point, you are simplifying your fractions, you are rationalizing denominators. All right? I can't simplify. Can I divide everything by a 2 here? No, how come I can't divide everything by a 2? Because it's not just 6 minus 2, it's square root of 6 minus square root of 2. Okay, remember you can't divide up by 2. Any questions on number 1? Okay, so the idea is you pick the formula. Once you find the pair of angles you add or subtract together, then you know whether you're going to use your sum or difference. If I add 2 angles, I'll go to my sum. If I subtract, then I'm using the difference. All right, let's take a look at number 2. Find the exact value of the tangent of 105 degrees. So I'm not giving you a hint here. So you need to think back. I'm in degrees, so look at your degree angle measurements. What 2 angles can you add or subtract to give you 105? Now, what I personally like to do is see if I can pick angles in quadrant 1, because that way I don't have to worry about having negative ratios. So can you think of 2 angles added or subtracted together from the unit circle less than 90 that'll give you 105? 60 and 45. Because you've got to be really careful of your signs. So I know 60 degrees plus 45 degrees equals 105 degrees. Could I have done 135 minus 30? Absolutely. All right, the only reason I try and use quadrant 1 angles so that way I don't have to worry about substituting in with negative ratios, because those negative signs could drive us nuts. Okay? So now I need to go on my formula sheet. I need to find my tangent sum formula. So tangent alpha plus beta. And again, I'm just going to copy the formula right from my formula sheet. Is tangent alpha plus tangent beta all over 1 minus tangent alpha tangent beta. Because you're going to do them and write them down enough that they're going to become second nature to you when you do your homework. You will. So now, eeny, meeny, miny, mo. Does it matter which one I really call alpha or beta? Do you agree with me? 60 plus 45 is equivalent to 45 plus 60. So it does remember. So I'm just going to call alpha 60 and beta 45. But you could certainly reverse it and still get the right answer. So again, I'm trying to find the tangent of 105 degrees is equal to the tangent of 60 degrees plus the tangent of 45 degrees all over 1 minus tangent of 60 degrees tangent of 45 degrees. Okay? Yes?
Why can't you just find the tangent of 60 and the tangent of 45?
Because again, because it's coming from special right triangles. Remember, when you do these ratios, you think about when we set up the unit circle, they're ratios from special right triangles. Okay? So now, thinking back to your unit circle, what is the tangent of 60 degrees? I'm in quadrant 1, so I know I'm positive. Square root of 3. Plus, what's the tangent of 45? That's the good one, remember? 1. All over 1 minus square root of 3 times 1. Okay? Am I done? Am I good? What's my problem? Actually. So, trig is done now. If you're good with everything I've done up to this point, you're good on the trig. You're good on the pre-calc part. I'm now moving back into the world of algebra land. All right? How do I rationalize this denominator? What do I have to multiply everything by? 1 plus square root 3. Okay? Again, if you want to rewrite square root of 3 plus 1 as 1 plus square root 3 to make your foiling easier, go right ahead, because square root of 3 plus 1, remember, is the same as 1 plus square root 3. All right? So again, when I FOIL the numerator, 1 times 1 is 1. Square root of 3 plus square root of 3 is going to be plus 2 square root 3. Square root of 3 times square root of 3 is just going to give me a 3. Over. Remember, when I FOIL a binomial as a conjugate, the outer and inners are going to cancel. So 1 times 1 is 1, minus square root of 3 times square root of 3 is just a 3. So now I can combine like terms in the numerator. 1 plus 3 is 4, plus 2 square root 3 all over negative 2. Any questions on what I've done? Now, can I simplify that? What can I divide everything by? I can divide everything by a what? Negative 2. So it's going to give me negative 2 minus square root 3. So there's the exact value of the tangent of 105 degrees. Okay? Tangents, as I've mentioned to you, are always your trickiest ones. And here's an example. The tangent sum and difference formulas, not that sine and cosine are pretty, but the tangent's going to require a lot more algebra because you're going to end up with a rational expression more than likely. All right, that's why I picked on that algebra review rationalizing denominators as well as simplifying rational expressions. All right, because I know you're going to need it in this unit. All right, so any questions on 2? So think to yourself for a minute in number 3. See if you can find 2 angles from your unit circle that when you add or subtract them together give you -5 pi over 12. So see if you can pick a pair of angles for me.